Hey everyone, welcome back to the channel. Today, we're diving deep into the world of VLSI very large-scale integration. Basically, this is the magic behind all the awesome tech we use every day, from the processors in our phones to the GPUs in our gaming rigs. Whether you're a student just starting out or a seasoned pro looking to expand your horizons, this roadmap will equip you with the essential knowledge and skills to conquer VLSI. We'll cover everything from fundamental concepts to advanced techniques. So buckle up, smash that like button, and let's get started. Alright, before we jump into the complex stuff, let's lay a solid foundation with the basics of digital electronics. You got to learn to walk before you can run, right? We're talking Boolean algebra, those magical logic gates like AND, Oregon, NOT, the building blocks of digital circuits. You'll understand how these gates combine to form more complex circuits like flip-flops, counters, multiplexers, and latches. Trust me, these are the unsung heroes of the digital world. And of course, we can't forget about finite state machines. They're the brains behind decision-making in digital systems. Now, to communicate with these circuits, we need to speak their language, binary. We'll dive into number systems like binary, hexadecimal, and decimal, and you'll become fluent in digital communication. Don't worry, it's not as intimidating as it sounds. A good place to start would be digital design by Mano and CMOS, VLSI designed by Weste and David Harris. They're like the holy grails for this stuff. Now that you've got the basics down, it's time to start talking to the hardware directly. How? With hardware description languages, or HDLs. Think of them like programming languages, but instead of telling your computer what to do, you're describing how you want your digital circuits to behave. VHDL and Verilog are the big players here, and trust me, learning them is like adding superpowers to your VLSI arsenal. You can find tons of awesome online courses on platforms like Udemy, Neptel, or Coursera. And hey, why not get your hands dirty with some real tools? Download Xilinx Vivado, Quartus Prime, or Model Sim. They're like the industry-standard tools for simulating and testing your designs. Start with simple projects like designing an 8-bit adder, an arithmetic logic unit, or a shift register. Remember, practice makes perfect, so get those fingers typing. Alright, time to pop the hood and see what makes these digital circuits tick. At the heart of it all lies CMOS technology, complementary metal oxide semiconductor. Sounds complicated, right? Don't worry, we'll break it down. We'll delve into the world of MOSFETs, those tiny transistors that act like switches controlling the flow of electricity. You'll learn about NMOS and PMOS transistors, the dynamic duo behind CMOS logic. We'll explore how these transistors come together to form the fundamental building blocks, the CMOS inverter, NAND gates, and NOR gates. And of course, we'll cover essential concepts like power dissipation, delay, and scaling, because efficiency is key in VLSI design. For this, you got to check out CMOS Digital Integrated Circuits by Kang and Leblebichi and Digital Integrated Circuits by Rabbi. Chapter 4. Gearing Up. Mastering the VLSI design flow and essential tools. Now that you've got a grasp of the fundamentals, it's time to get your hands dirty with the real deal, the VLSI design flow. Think of it like a recipe for creating complex integrated circuits from the initial idea to the final product. We'll walk through each stage from HDL coding and simulation to synthesis, where your code transforms into a physical circuit representation. And of course, no VLSI journey is complete without the right tools. We're talking industry-standard software like Xilinx Vivado and Quartus Prime for HDL coding, Synopsys Design Compiler, and Cadence Genus for synthesis and optimization, and Cadence Innovus and Synopsys IC Compiler for layout and routing. And hey, if you're into analog IC design, Cadence Virtuoso and ngSpice are your new best friends. Remember, the more comfortable you are with these tools, the more powerful you become as a VLSI designer. Chapter 5, FPGA Playground, diving into the world of FPGA development. Ready to bring your designs to life? FPGAs, or field programmable gate arrays, are like digital playgrounds for VLSI enthusiasts. These reconfigurable chips allow you to implement and test your designs in hardware, giving you instant feedback and endless possibilities. We'll explore the architecture of FPGAs and learn how to program them using the HDLs you've mastered. And hey, what better way to learn than by doing? We'll dive into some exciting FPGA projects, from the classic LED blinker to more complex designs like UART communication modules. And of course, we'll introduce you to some popular FPGA boards like the Xilinx Nexus A7 and the Intel DE10 Nano, your gateways to the world of hardware hacking. If you're looking for a good resource, check out FPGA Prototyping by Verilog Examples by Pong P. Chu. Chapter 6, ASIC Adventures, Navigating the ASIC Design Flow. Alright, you've conquered FPGAs, now it's time to level up to ASICs, Application-Specific Integrated Circuits. These custom-designed chips are the backbone of high-performance electronics, but they also come with a more complex design flow. Don't worry, we'll guide you through every step from defining specifications and creating RTL designs to the intricacies of synthesis, floor planning, placement, routing, and timing analysis. We'll even touch upon the world of fabrication and testing, because what good is a chip if you can't manufacture it? Get ready to wield industry-standard tools like Cadence Virtuoso for analog design and Synopsys IC Compiler for digital place and route. ASIC design is where your VLSI skills truly shine, so get ready to unleash your inner chip architect. Alright, it's time to put all that knowledge into practice and build something awesome. Mini projects are your secret weapon for solidifying your VLSI skills and impressing potential employers. We'll walk you through some exciting project ideas, from designing a 4-bit ALU in Verilog to implementing a UART module for serial communication. How about creating an FPGA-based digital clock, or optimizing the power and area of CMOS logic gates? And hey, don't forget to showcase your hard work. Create a GitHub repository and upload your project files and documentation. It's like a digital portfolio for your VLSI skills. Trust me, recruiters love to see tangible evidence of your abilities. Chapter 8. The learning never stops in the world of VLSI. Luckily, there are tons of fantastic online resources to quench your thirst for knowledge and boost your credibility. We'll point you towards some highly regarded online courses, like the MPTIL VLSI design courses offered by IIT Madras. They're like the gold standard in VLSI education. Coursera's VLSI CAD Part 1 and 2 is another great option, and if you're looking for something more specific, Udemy's Verilog and FPGA design course is top-notch. And hey, don't underestimate the power of YouTube. Channels like VLSI Academy and FPGA for Student are treasure troves of valuable information and tutorials. Remember, the more you learn, the more valuable you become in the VLSI industry. Chapter 9. VLSI is a collaborative field, and connecting with fellow enthusiasts can accelerate your learning and open doors to exciting opportunities. We'll introduce you to some vibrant VLSI communities, both online and offline. Join VLSI-focused Discord servers and LinkedIn groups. They're buzzing with discussions, shared projects, and valuable insights from experienced engineers. And hey, why not put your skills to the test in VLSI hackathons and competitions? They're not only a ton of fun, but also a fantastic way to network with potential employers and showcase your talents. And speaking of employers, we'll also discuss internships, your golden ticket to gaining real-world experience at industry giants like Intel, Qualcomm, Cadence, Synopsys, and NVIDIA. Chapter 10, congratulations, you've made it to the final chapter, planning your VLSI career. With your newfound knowledge and skills, the possibilities are endless. We'll explore different career paths within the VLSI domain, from front-end VLSI engineers who focus on HDL design and verification to back-end engineers who specialize in synthesis, layout, and physical design. If you're passionate about FPGAs, you can become an FPGA engineer, developing cutting-edge solutions for various industries. And if custom circuit design is your calling, then an analog IC designer might be the perfect fit. We'll also discuss higher education options like pursuing an M.Tech or MS in VLSI design at prestigious institutions like the IITs, ISC, or renowned foreign universities. Remember, your VLSI journey is just beginning, and with dedication and hard work, you can achieve incredible things. So there you have it, your comprehensive roadmap to kickstarting your VLSI journey. Remember, VLSI is a vast and ever-evolving field, and the best way to master it is through hands-on practice and real-world projects. Start with the fundamentals of digital design, dive into the world of HDLs like Verilog and VHDL, and familiarize yourself with those powerful EDA tools. Don't be afraid to get your hands dirty with FPGAs and explore the intricacies of ASIC design. Remember, every VLSI expert was once a beginner, just like you. Embrace the challenges, celebrate the victories, and never stop learning. Good luck on your VLSI adventure. The future of technology awaits. Don't forget to subscribe and hit that notification bell for more awesome content. Until next time.